Alright, so we're going to continue on with Chapter 1. I will go over a couple of things at the end, and then you will have some time in class to work on some homework and stuff. Okay? Alrighty, so, well, I'm supposed to give them out to I forgot to give them out to you guys. I forgot to give them out twice to my 5th period. Yeah, not that funny. Yeah, I didn't think it was that funny. Alrighty, hey, it's 9/1, September 1st, isn't it? And this is Chem 1110, Chapter 1, Day 2. And our objective is going to be able to better understand and calculate significant figures. Now, this is probably one of those things that will make most of you wish you had paid better attention in your math class. No, not really. This really isn't that bad. Now, does anyone know what that term even means? And I will never write that again. From now on, I will simply write sig figs like that. Okay, does anybody know what the term significant figures even means? Not a soul. Okay? What sig figs is these are basically the numbers that matter in a calculation. Now, I'm going to teach you, 3 or 4 things you just have to know to be able to do this. Okay? And then we'll do some of these, and I'll show you a couple of little, I don't want to call them shortcuts, but a couple little things you can look for that are going to help you get this. Now, what happens is this. In any number, and it doesn't matter what it is, if I've got, let's say I've got 36,402, okay? This has 5 sig figs. Now, if it's a number, it's what's called significant, no matter what. The only one that doesn't apply to is the number what? Anybody know? Nope. 0. Okay, 0 is the only thing you got to watch out for. Now, in this problem, or in this number, 0 counts. And it counts because it is what is known as captive, which means it is between 2 other non-zero numbers. Okay? So anytime you have a 0 in the middle of a number, it is significant. Okay? Now, that's different than if I have this. Let's say I have that. Okay? And a lot of times they'll write a 0 out in front here. Okay? In this situation, this has 1 sig fig. Okay? Now, none of these zeros matter. None of them matter because they're what is referred to as basically placeholders. Okay? And these are what are referred to as leading zeros. Okay, leading zeros, and they don't matter. Okay? The same thing happens if the 0 is at the end of a number, as long as there is no decimal. Like if I wrote 8,000 like this, that has 1 sig fig. Okay, and they are what is referred to as trailing zeros. Okay? Now, this changes if I put a decimal there. So if I went like this, and I put a decimal there like this, I don't even have to have a 0 after that. I just have to have a decimal point in that number. Now that number has, how many sig figs you think? Now it's got 4 sig figs. Now here's the difference, and this is what you need to understand. Is what that decimal means, what that decimal is trying to tell you, is that I actually measured that, and it came out to be exactly 0. A lot of times in a number like this number's been what, you think? I heard it. It's been rounded. If it's rounded, you really don't know. Okay, so if it's been rounded, I can't say I've got a whole bunch of significance there when I really don't. Okay? So what we're going to do is we're going to play the raisey handy gamey. Okay, don't furrow your brow at me, Miller. So what happens is this. So I'm going to write down a number. And you're going to raise your hand when you figure out how many significant figures that has in it. Okay? And then I'm going to give you a number. And you have to remember that number because I'm going to call out number 12. Or whatever number I get to, and that's who's going to answer the question. Okay? So if I wrote down this, and I said, how many significant figures does that have in it? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, who is number 7? Did I not mention you're supposed to remember your number? Oh, you were 4. Yeah. But I said 7. Who was 7? So 7 had to be this way of her. Nobody remembers they were 7? Okay, what do you got for me? 6. 6? Yeah? So 1, 2, 3, 4, 5, 6. What about those zeros? Okay, but it has a decimal in it. If it has a decimal in it, guess what? They count. It is 8 sig figs. The minute a number has a decimal in it, once you get to a digit, you start counting. Anything after that, because that means that I actually did what with that 0? What did I say that decimal meant? I actually measured that, and it came out to be 0. I can't round like that. Can you round? You know what I'm saying? You're not rounding to the nearest 10th, 100th place. You see what I'm saying? That actually counts. Now, if I did this, how about that one? One, 2, 3, 4, 5, 6, 7. You can put your hand down after I give you a number. 8. Let's go to 10. 9. One more. 10. There you go. Who's number 3? Did I not mention you were supposed to remember? Remember? Yeah, you were 1. You were 2. You were 5. Okay, Kaiser, you're up. 1? Is he right? Why not? 3. Because remember, this number has a decimal in it, right? If they're to the left of that number, they're leading zeros. They don't count. But once I hit a number, now they all count. Because that means that I went 4, I measured all these digits, and they just happen to come out to be 0, so now they count. Okay? So, now, remember your number. If I'm not making good enough eye contact with you, I will try to do that better. Okay? One, 2. Is that a maybe or is that a what? Let's go 3, 4, 5. 6. We got to get to 10. I got all day. I'm not going anywhere. 7, 8, 9, and almost 10. Hunsaker, what do you got for me?
Oh, you called out a number.
Yeah, I usually do.
I was thinking 8.
You were thinking 8? Why 8? Yeah, why 8? Yeah, so you're thinking this is going to change it, right? It doesn't. It's only what you can see. That number has 5. No matter what that says, I've got to go off of the number I can see. Okay? Now, what's going to happen? And this is one of those things that is a lot like math class, in that the only way you ever, and for most of you, you already know this, the only way you got good at the quadratic formula was by doing what? Doing the quadratic formula. Okay, so what they're going to do is they're going to start out with just, here's some numbers, tell me how many sig figs in it. Then they're going to start doing what?
Throwing in the decimal or something.
Well, yeah, but beyond that, what are they going to expect you to do? Solve problems with them, right? So now we're going to do some calculations. Now, this is one of those things that you will never, ever, ever be able to do, if you don't practice. Okay? It's just, I don't know. It's like shooting a free throw. You're never going to get any better at your free throws if you don't practice. Just ask Shaq. Anybody that got that, you can probably see the humor of that. Now, what they're going to do is there's really only 2 rules to sig figs. There's addition, subtraction rule, multiplication, division rule. Okay? So in add or subtract, okay, it is the number to the right of the decimal. I missed a word in there. It's the least number to the right of the decimal. So if I had 3.726 and I add that to 1.19, okay, what am I going to get? Somebody give me the answer. Well, it's 6 and 1 and 1 and 9 and 5. 5.916, right? Now, oh yeah, it is 4. I carried my 1 to the wrong number, didn't I? So look, so this is what you get mathematically. Okay? Now, that is not going to be the answer. It's not. Okay? If I go back to here, in a calculation, adding and subtracting, I'm going to have the least number to the right of the decimal. Well, how many digits does this have to the right of the decimal? It has 3. How many does this one have to the right of the decimal? 2. How many can my answer have to the right of the decimal? 2. It's got to have the least number. So the 2 dictates it. So now I'm going to do what to this? I'm going to round it. Now, something I saw happening last year that kind of baffled me. How do I round? Anybody know? Miller?
Well, if it's a 1 group where you round down to 0, if it's like 5 or greater, then you'll round it up and then add 1 to the next number. So like since that's a 6 is greater than 5, so you'll round up and the 1 will become a 0. So
you're going to make that 4.92.
Yeah.
What if I had other digits out here? Do they... What?
It would still just be 4.92.
Okay, why? Okay, so that's the key, Simon, is that it's just this number. I had a kid last year that started at the end, and he rounded every number until he got to where he was going. And I'm like, yeah, that's not how it's done. It's only the one right after where you're rounding to. Nobody in here's ever seen that before? Yeah, I was baffled. Just baffled. I'm like, somebody needs to smack your teacher. Now, here's my question. How many significant figures does that number have in it? Yeah, it's got 3 because they're all non-zeros. If they're all non-zeros, it makes it easy. Okay? Now, multiplication and division. Okay, multiply and divide, that is the least total sig figs. Okay? Meaning, if I'm going to take 247.6, I'm going to times that by 1.29. Okay? Now, this number has how many sig figs in it? 4. This number has 3. What's my answer going to have in it? It has to have 3 because that is the least significant number. So I do this multiplication and I get what? You guys probably should treat this as a math class. Okay? Which means you should probably do what? What do you think I'm trying to tell you to do there? Is that louder? Well, I would say at least bring a calculator, and from now on you can't use your phones. Well, no, from now on you can use it today. The reason I say that is because you can't use your phone on the test. So there's no point in being used to using your phone and then having to use a You guys all understand what I'm saying there? Okay? So yeah, no phones as calculators in this class. Somebody got me an answer?
Yeah.
I want the whole answer though. Zog, what do you got? 319.404, like that?
Yeah.
Okay? Now, my answer though can only have what? 3 sig figs, no matter what. No matter what. So I'm going to round it right here, correct? So that's a 4. So that's just going to be 319. Can I put a decimal there? I don't know. Does that decimal change that answer at all? Is there a situation where that decimal might change my answer? Yeah, if this was a what? 0, right? Then it would change it. So you got to be kind of careful. That or that, they would be the exact same because they both still just have 3 significant figures in it. Okay? Now, let's do this. Let's go lazy handy gamey. Okay? So let's go. Let's do that. And let's get 7 hands. One, 2, 3. You were 1. You can put your hand down. You were 3. Miller, you put your hand down. Buck, you were 2, right? 4, 5, 6, 7. Alrighty, so Brodnick, what do you got for me here?
Wouldn't it just be 15?
Wouldn't it just be, I don't know. I'm not the one answering the question here.
Well, that's what I think it is.
Brodnick thinks it's 15. Anybody agree with 15? Okay, why do you agree with that, Hunsaker?
Because the 7 has no numbers to the right of the decimal. So the answer has got no numbers to it.
Exactly. No matter what, no matter how many significant figures I have total, remember, addition and subtraction is only talking about the ones that are to the right of the decimal, right? The number to the left, no matter what, is going to get either bigger or smaller. That's the nature of addition or subtraction, right? But because this one has no digits to the right of the decimal, my answer can have no digits to the right of the decimal. Does that make sense? Now, what if this became a multiplication problem? How would that change this? Well, let's do that. Let's go 4.76 times 3.2934 times 7. Let's go with 7 hands again. 1, 2, like your boots. Am I still only at 2? 3. Start playing the Jeopardy theme. 4, 5, 6, 7. Alrighty, so who was 4? Is that you, Zog? What do you got for me? 110? Is he right?
I thought it was 7.
You thought it was?
109.74.
109.74? Is he right? Anybody got something different? Talbot! You're awful quiet back there. That's unlike you.
I got 109.736088.
109.73.
6088.
And then it's the total, oh wait, it's the least. I did the most. Never mind.
Tamir, you talking to Jimmy? What do you got?
I think I'm 31.
So just one?
What I'm doing,
That's
I'm
another
trying to
100.
do the 968, because that doesn't change the significant numbers.
Okay, well, let's look at this.
It was
This one has 3, right? This one has 5. This one has 1, right?
And it's the least total.
It's the least. I'm doing multiplication, right? So my answer could only have one significant figure in it. It would be 100. Okay? Now, this would be a situation where that decimal would change things, right? That only has one sig fig because there's trailing zeros, there's not a decimal, they don't count. If I were to put a decimal there, now I've got 3, now I'm going to get it wrong. Okay? Now, that rounds a lot. Okay? And that's why significant figures are important, because the better your data is, the better your what? Nobody? Better your answers are going to be. You know, it's like if I'm making a cancer drug and I'm off by that much, is that probably going to be a big deal? Yeah. So what they're trying, and why sig figs are important, is when we go into the lab, the better data you have, the better your answers will always be. Okay? And when I go out into the real world and I'm working at a place that's making, you know, dialysis equipment or things like that, it does become a big deal. Okay? Alrighty, now, from there, one thing you do need to do, and I don't have a good way to memorize this, is you need to know this chart. Okay? You need to know the metric scale. Okay? I will say, I couldn't find it, I looked for it last night, but does anybody know what we use in America? What? Anybody know what system we use in America, what it's called? It's called the standard system. Okay, do you know why it starts with an S? Well, I was going to say because it sucks. It does. Why does it suck, Hunsaker?
It doesn't follow certain rules like
Okay, so I'm on Facebook, and yeah, that's an old person thing. But anyway, there was a picture of the world, you know, one of those flattened ones, and there were only 2 countries that used the standard system. It said it was making fun of America, and they were right. And it says, hey, look at all the people that use the standard system, and it was us and somebody else. And I'm like, well, that's stupid. Why is the metric system better? It's all in the same base. It's all in the same base. No matter what, everything is done by a unit or a factor of 10. Whereas in the standard system, you know, I got some things in 16ths and some things in 12ths and some things in 5,280s. Yeah, the conversions all suck. Okay? You are going to have to know this. How to go from one of these to the next. Now this starts off with units of 10, and then it goes to units of thousands or thousandths. But you need to know at least those 1, 2, 3, 4, 5, 6, 7, 8. Know them. Or write them down on your 3x5 for the test. But you've got to know how to use them. Okay? Yes? It's on page 10 in your book. I just pull it up, then you'll have it good. Or come up after and take a picture. But yeah. Write it down, your 3x5, whatever. I mean, most of this is stuff I'm hoping at some point in the past you've worked with, but there's no guarantee. Okay? Alrighty. Now, from there, we are going to start into what is known as dimensional analysis. Okay? Now, what we're going to do in dimensional analysis is we're basically going to convert from one set of units to another. And typically we're going to do this multiple times. So for example, let's say I wanted to know how many inches are in 7.36 miles. Okay? Now, this is what I'm going to start with. So I'm going to start with 7.36 miles. Okay? Now, this is called a lot of different things, and everybody has their own little way of doing it. I'm going to show you how I do it, and I approach it more mathematically than a system, but it all works pretty much the same thing. Now, what I'm going to do is I'm going to start here and I'm going to end up over here. Okay? I'm going to start in miles. My units when I'm done have to be in what? Inches, right? Now, is there what is called a conversion factor? So what you're going to need is, I'm going to use two different kinds of terms here. I'm going to use the term conversion factor, and I'm going to use the term equality. Okay? Now, does anybody know an equality that would help me get from miles to inches?
1 mile equals 5,280.
So 1 mile equals 5,280 feet. Okay? That's an equality. Now I'm going to take that equality and I'm going to turn it into a conversion factor by writing it as a what? Anybody know? What? As a fraction. Now, how will I want to write that in order to be able to use that in that problem? Anybody know?
Did you put the 1 mile on the denominator?
Wow, I'm impressed. Did you notice what he said there? What? Denominator instead of bottom. We use math terms in here. We don't ever say the bottom or the top. Okay? So 1 mile is going to go in my denominator and 5,280 feet are going to go in my numerator. Now when I put that into my equation, I'm going to go 5,280 feet. I'm going to go 1 mile. Now what is that going to allow me to do?
Cancel out the miles, so you have the feet.
What are my miles going to do?
Reduce.
I know your math teacher. Yeah, they're going to reduce. Because cancel conjures up what in your mind? To me, it's 0. It's not a 0 there. They reduce out because there's always a what left? Always a 1, right? Now, that puts me into feet, right? But I need to be in inches, so what's going to go next? Feet and inches, right? So what conversion factor or equality do we know? So how would I write that for the conversion factor that I'm going to want to use here? Where does my feet have to go? Yeah, my feet have to go in the numerator? No, feet in my denominator because I need them to reduce out, right? So I'm going to go 1 foot in the denominator. What's going to go in my numerator? 12 inches. Now, my feet are going to reduce out. What are my units that are left now? Inches. Well, is that what I wanted to end up in?
Yeah.
Yes. So now, I just do the math, right? So do that math. Give me an answer.
456,329.6.
Okay, so say that a little slower.
456,329.6.
That's inches. Right? Now, is he right?
Yes.
If he puts that on the test, is he right?
No.
Why not? Because of the sig figs. Okay? Now, a little trick you're going to learn here is this. Is that whatever they start with is going to be what they end with. Because your conversion factors should never impact that. Okay? And the reason I say that is this one only has how many sig figs? 2. But it is an established conversion factor. And if it's an established conversion factor, it doesn't impact your answer. So 99% of the time, all you've got to do is you've got to look at the number of sig figs you're given and make sure that your answer has the same number of sig figs. Okay? This has 3. My answer can only have 3. How am I going to write that to make this look the best? Zog. So 466,000 like that. Inches. Got to have units. An answer. One thing you will learn, an answer without units is wrong every time. Okay? I could do that. I would not. Let me know what I would do. 10 to the 5th. How'd you get that? Yeah, I went. It would have been here, and I went 1, 2, 3, 4, 5. Right? Got to have inches on there as well. These two are technically the what? The same. Sometimes they write it this way. Sometimes they write it that way. Just make sure as you're taking the test, you look through all the answers to make sure, and they won't be on there. They both won't be on there because they're the same. But make sure you check through and make sure you're getting it right. Okay? 3 sig figs. Each of those only have 3 sig figs. That has 7. Does that make sense? Okay? Now, let's say I did this. Let's say I went with, let's say I went 2.634 times 10 to the 8th inches. And I want to go 2 kilometers. Let's say I wanted to do that. Okay? Now, I'm starting with this, 2.634 times 10 to the 8th inches, right? I got to get to kilometers. Anybody know how to get from inches to kilometers? Wow. Anybody know inches to anything metric? Not a soul? Wow, that's scary.
I know,
Oh, but if I did that, I'd have to go all the way to miles and go back to kilometers.
Centimeters.
Ah, who said that? Yeah, that's what I would do. What do you got for me, Hunsaker? 2.54. That's what I was. Yeah. Here it is. Just a second. I've got a really nice little conversion factor right here, and I'm trying to remember if we could get more. There's not. So they're just going 2.54. So I would go 2.54 centimeters in 1 inch. My inches reduce out, right? That's going to put me into centimeters. Now, how do I go from centimeters to kilometers? Can I go right from centimeters to kilometers, or is there a better way? What is it from centimeters to kilometers?
Oh, because the centimeters at 100.
Yeah, so what I would do is I would go from centimeters to meters, and then I know meters to kilometers, because now I know that's a, what? 1,000, right? So how would I go from centimeters to meters? Well, I would go, but remember, I've got to use things so I can get rid of my units, right? So I would go, what here? 1 meter is 100 centimeters, right? Now again, this is an exact conversion because that only has one sig fig in it, right? But is that going to impact my answer? No, because that's a standard conversion, right? What's next?
Meters are the denominator, and then it's a kilometer on top, right?
Okay, so
In the numerator, right?
so I go 1 kilometer in my numerator, and I go 1,000 meters in my denominator, right? So now my meters reduce out, my centimeters reduce out. I'm going to be left in my only units that are left are kilometers, right? So, do that math. Do we all know how to use the E button on our calculators for scientific notation? Yeah, watch. If you have one of mine, you use this button right here. So I would go 2.634 second E button. That E means times 10 to the 8th.
The double E1?
Yeah, the double E1 puts that E in, and that E means times 10. Okay, that's the best way to do it. Okay, if you use the whole 10 to the X, it screws you up.
Hey, that's fancy.
Okay, what do we got? Somebody give me the whole answer. Nobody's got the whole answer yet?
Wait, how many sig figs?
No, I want the whole answer, then we'll do sig figs.
2,634,000, and then it's 0.025 at the end. So it's like 634,000, so 2,634,000, 0.025.
0.25 like that. Anybody else get that? You didn't get that, Simon? No?
That's a whole lot of kilometers. Yeah. Oh wait, I only divide, never mind, I did it wrong. I gotta divide that by 1,000. 2,634?
No, this should get way what? Way smaller, right? 0 point, say it again, 0 point. 0.864469984. Anybody else get that? Simon, no, you didn't get that either?
I got 6,690.36.
Yeah, that's
6,690.36. Well, let's look at this. So I already got that, right? Then I'm going to times that by 2.54. That's all my numerators, right? And I'm going to divide that by 100. And then I'm going to divide that by 1,000, right? I get 6,690.36. Okay, so we got this, right? Now, that has 6 sig figs, right? My answer can only have what? 4, right? Now, which means that I'm gonna round right there, correct? Well, technically I'm gonna round it right there, but the decimal's gonna stay, so that 3's lower, right? So that should stay 6,690, right? Oh, sorry. So that should stay 6,690, right? No, why not? Because technically there's only 3 because there's no what? Decimal. So what would I need to do here? I could just add the decimal like that. Now it has 4 sig figs. What would be a better way to write that?
6,690.0?
No, because if I go 6,690.0, because my decimal's there now, that other 0 would 6.69 times 10 to the 3rd?
Yeah.
Is that right? Why not? Because that one only has 3, it would have to be 6.690 times 10 to the 3rd, and none of those have units, that should be kilometers. Okay? Now, this is what happens. There are lots of little ways for you to do what here? To screw this up. This takes practice. Okay? Practice, 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 practice. Okay? Now, one thing, let me look at something really quick. Yeah, if you look right here, and this is something that, I don't know, some of you are going to know some of these. These are some common conversion factors, if you will. These are actually written like this. What would all of these be considered? Anybody know what these would be considered written like this? An equality. Okay, it's not a conversion factor until I write it as a what? As a fraction. And then I can write it either way depending on what I need and what I need to get rid of, right? So there are times if I go back to like here, 12 inches and 1 foot, might there be a time where my foot's in the numerator? Yeah, which is why it's important to understand that the equality looks like this. The conversion factor is whatever I need it to be, whichever way I write it, depending on where I want to go. Now, I would not go and try to memorize or write a bunch of these down. Okay, there are some you do need to know, though. This one, 2.54 centimeters in 1 inch, that is important. 1 mile is 5,280 feet, that's important. But again, any of these are considered exact, so they don't count on your significant figures. There's one other kind of number that doesn't count. Okay? Counting numbers. Counting numbers do not impact sig figs. Okay, so if I counted 7 people, that would not impact my sig figs because that's exact. Okay, in theory you could say it has an infinite number of sig figs. I can't have a part of a person. Nobody's going to cut their big toe off, right? Counting numbers. I counted 12 eggs. That doesn't impact my sig figs. Okay, you can go off of something else. Okay, counting numbers do not impact sig figs, so just pretend that they don't even exist. Just use it as a number. Again, if I go back and at the end of the year, we'll be doing this still. Okay. All I've got to remember is that if whatever number they give me in my problem, if it's got 7 significant figures, my answer would probably better have what? 7 significant figures. Okay? Very seldom will that ever change. Okay? In fact, I'm thinking back to last year. I can't think of a situation where that is going to change. Okay? Is that making any sense? All right. Now, last thing I want to do is I want to oh, crap. I just realized I forgot to print you off the periodic table. Hey Siri, set a reminder for 12:30 to print off the periodic table. Or don't. Ignore me like my kid does. Hey Siri, set a reminder for 12:30 to print off the periodic table.
Okay, your reminder.
There we go. All right. So, what's going to happen is they are going to get into actual, periodic table stuff. All this stuff to me is more just math. Now, let's say I did this. Let's say I said, how many moles are in 276.4 grams of, I don't know, let's say I said sugar. Okay? Now, I know I'm going to start with 276.4 grams of C6H12O6. Now, who in here knows what we have to do right here? Anybody have any idea how I'm going to go from grams to moles? You don't even know what a mole is. Anybody know what a mole is? No? Nobody? 1 mole is 6.02 times 10 to the 23rd atoms, molecules. They're typically, they will introduce you to FUs. What? Spell what? M-O-L-E. Sorry. M-O-L-E. 1 mole is 6.02 times 10 to the 23rd, whatever you're talking about. Okay? It could be in atoms. It could be in molecules. It could be in formula units. Hell, it could be in dogs, cats, cows. It doesn't matter. Okay? Now, here though, I'm in grams. So in this situation, it's a little different. What I would do is I would go to the periodic table and I would find what is known as the molar mass. Okay, does anybody know what the molar mass of something means, what it means? Nobody in here took regular chemistry last year? Somebody had to have taken regular chemistry last year. Nobody? Molar mass is the mass in grams of 1 mole of whatever you're talking about. Okay, now let me explain something really quick. Let me find my periodic table. Okay, here we go. Now, here is my periodic table. Okay, so let's look at this right here. This doesn't zoom very good. Let's say I take a look at carbon, right? Okay, here's carbon. Now, right here, this little red number, that is its mass. Okay? Now, if I wanted the mass of an atom of carbon, how small are atoms? Really small, right? That number right there, the 12.0107, is in what is called AMUs, which stands for atomic mass units, which is a very small unit, right? But if I am talking about a mole of carbon atoms, which is usually what we'll be talking about, now the number doesn't change, but its unit does. Okay? So the mass of a mole of carbon is 12.0107 grams now. Okay? So what you would do, you would say, okay, I need to figure out what the mole of sugar would have a mass of. Now, this is what you would do. You'd say, well, I've got 6 carbons, right? I've got 6 carbons, and each carbon has a mass of, what did I just say? 12.0107 grams. And then I've got 12 hydrogens. I've got 12 H's, and an H has a mass of 1.007. Wow, I gotta start wearing my glasses. 794 grams. And then I've got 6 O's at 15.9994 grams. Okay? And then you would do this multiplication. So I would do that. And somebody do these. 3 people do these calculations for me. Anybody got the top one? Not a soul knows how to do those calculations. Nobody can get me this first answer.
I got 72.0642.
72.0642. Anybody get the next one?
I got 12.0958.
How about the last one? 95.9964. Okay. Now, here's a really good question. Are any of those answers right? Why not, Tamir? Exactly. So this one can have how many significant figures in my answer? 6. So I got 1, 2, 3, 4, 5, 6. Does that 6 count? Why not? Counting number, exactly. So that has 6. Does my answer have 6? Okay, so that one works. How about this one? It has 1, 2, 3, 4, 5, 6. My answer though has 1, 2, 3, 4, 5, 6, 7. So I'd have to take and get rid of that 8 and make that a what? Make that a 3, right? Okay, what about this one? That has 6, this one has 6, we're okay, right? Now I'm going to add them all up. Okay, so somebody add them all up, that's now a 3. And let's see what I get here. Nobody? 180.1549. Is that what you got, Blodnick?
Yeah.
Yeah? Is she right? Okay, so let's look at it now.
So each number is right.
Exactly, because now I am doing a different process, right? Now I'm adding. Each one of these have 4 digits to the right of the decimal. My answer can have 4 digits to the right of the decimal, right? And that would be in units of grams, right? Now this right here is what 1 mole of C6H12O6 equals. 180.1549 grams. So I go back up here as my conversion factor. What's going to go in the numerator and what's going to go in the denominator? What unit has to go in the denominator? Grams have to. So that's my 180.1549 grams in my denominator and mole in the numerator. Sorry. My grams are going to reduce out, right? I'm going to be left in moles of sugar. I do that math, I take that and I divide it by that. What does my answer have to be? What? Oh.
So it's 4, so that would be 1.534.
1.534? What did your calculator spit out?
1.534,
1.534.
235, 261.
Okay, well, clearly I can't have that many. He was right. I got 4 there. My answer can have 4. Did you round that right? Okay, what's wrong with that? Yeah, I got to have units. That'd be 1.534 what? Moles of sugar. Is that not right? Did nobody else back that up? You got that? Okay. And that's where we're going to go eventually. Okay? I've talked too long as it is. Alrighty, so last... What time do we get out now? 9? So the last 20 minutes is yours. Get your Chromebooks out and let's get after it. Now, is there anybody besides Dallas that is still having issues getting on?